2014's been another big year for science, with key discoveries and developments over the past 12 months, from the outer space achievements of landing on a comet to the inner space of the human body and the rise of the superbug.
To take us from outer space to inner space, we're joined by two of our regular science experts, AUT's Steve Pointing and Massey University's Heather Hendrikson. Good morning.
Good morning.
Thank you for coming in. Right, Steve, let's begin with you. Outer space. What mysteries of the universe have come a little closer to being solved?
Oh, wow. Well, this was a tough pick because there's so much going on in space. We've got rovers on Mars, we've got space telescopes, but for me it was Rosetta, which is the mission primarily led by ESA, the European Space Agency, to land on a comet. So this is an incredible feat. We've got a comet whizzing around space 800 million kilometres away. This sort of 100-kilo package has managed to rendezvous with it after a 10-metre journey, land on the comet, and almost immediately, within days of landing, has started to give us incredible information. I regard it as quite transformational because one of the things I love is astrobiology, and that is the study of whether or not life could exist or possibly did exist on other planets. And what this has done is really add a lot of weight to this idea. So what the Rosetta mission has done is analysed the water on this comet and found that it's fundamentally different from any of the water on Earth. Now, this debunks a very popular theory that comets seeded the early Earth with water and thereby allowed life to develop because water is necessary for life. So attention has now turned almost completely around to another type of celestial body, and that's asteroids. These are rocky bodies primarily, but they also contain water and, importantly, organic compounds. And so what we now think is happening, or has happened, is that these asteroids were the major source of water on early Earth. Now, the reason why this is exciting is because the major period of asteroid bombardment on Earth was about 3.8 billion years ago. Now, our earliest evidence for life on Earth was about 3.8 billion years ago, so it really narrows down the gap of when we estimate life began on Earth. And this really is a fundamentally game-changing discovery.
So, Heather, what's NASA planning next?
I think, so this is actually really fun to me. So the next thing that NASA is planning on doing is actually getting up close and personal by sending a spacecraft out to an asteroid, lassoing the asteroid, dragging it back to the moon, and putting it in rotation around the moon. And then that spacecraft that they recently shot off, Orion, that did the kind of 4.5-hour loop around the planet, is going to be sent off with a suite of astronauts in order to study up close and personal this asteroid that they rope and set around the moon.
Doesn't sound difficult at all.
No,
like
it's the kind of like,
Western,
they're using the word audacious, which I think is fair. It's the kind of thing that when they were first proposing landings on the moon, I'm sure they felt exactly the same way as I do, and I'm sure you do, about lassoing an asteroid and dragging it back. But that's the first step. And then the steps after that are going to be sending people in the Orion spacecraft to Mars. So they're hoping to do that by the mid-2030s.
Right, inner space time now. Steve, how concerned should we be about the continuing rise of the superbug?
Well, this is unfortunately a huge concern. A few numbers put this in perspective. So at the moment, about 700,000 people a year are estimated to die from antibiotic-resistant bacterial infections. By 2050, it's been estimated that could rise to 100 million, which is more people than die every year from cancer. So this is a huge issue. Now, really, this is due to three major causative factors. The first is that use of antibiotics is, for want of a better word, reckless. Now, this is not just in terms of human use, but in terms of livestock. So about 70% of global antibiotic use is for livestock, and it's often at subtherapeutic doses. Also, the microbes themselves evolve mechanisms to overcome antibiotics very quickly. And also, thirdly, and very worryingly, pharmaceutical companies have dramatically reduced the amount of investment they put in antibiotic R&D recently because it's simply not profitable. There's a lot more money to be made, for example, in antidepressants than there is in antibiotics. But what is encouraging, and this is not so much a science solution as a policy solution in science, is that governments are now getting behind and acknowledging this problem. So the UK government has announced the Longitude Prize, which is a £10 million prize for discovery of a rapid diagnostic test for these bacteria. And President Barack Obama of the US has also recently announced a presidential directive with a similar focus to try and establish a really good rapid test to help us more effectively and responsibly diagnose and manage antibiotic use.
And Heather, what about breakthroughs in our learning about the body? The Nobel Prize for Chemistry, I gather, was a big breakthrough.
Right. So the first step, of course, was that light microscopy. Since it was invented, we've thought that we could only get as small as about half the wavelength of light, and that was the smallest things that we could possibly see. And what they really did this year with the chemistry Nobel Prize was awarded to 3 scientists who had shown that we could surpass that, and we could take single frame images where we compile the information that we're getting from light in such a way that we could get down to that kind of almost nano level. And then the amazing thing was that in the same month that the Nobel Prize came out, Eric Betzig from Howard Hughes Medical Institute published a paper on a brand new technique that can take that technology and actually make 3-dimensional movies of fluorescent proteins live in cells and in tissues. So that was just amazing. And the kinds of technologies that they're coming out with, the new microscopes that they're building, are just going to blow us away.
Okay, well, have a very Merry Christmas, you two, and thank you very much for coming in throughout the year.
And we're looking forward to that lassoing of the asteroids.
Space Cowboys, right?
Will it be live on television, I hope?
One can only hope.
Thanks very much.
Thank you.